we'll make it work today. So we have to take the function that is written currently. This is in intercept form. So right away you could know your zeros, which maybe I'll do that to start. Since I'm already in my intercept form, if I set the equation equal to 0, oh, this can be a, there we go. Okay, sorry about that. Let's see if this works again. Okay, so I'm actually going to do part 3 first. I want to find the zeros. Well, the first thing I would do is get rid of that 2 and divide everything by 0. And then we can use the zero product property, which says each one of these parentheses could be equal to its own 0. So I'm going to set each one equal to its own 0 and solve. I get x equals positive 5 and x equals minus 2. So then thinking about what that looks like on the graph, your zeros are the spot at which it crosses the x-axis. So I'm going to go over -2. And I'm just going to label it. If you really want to, you can put the coordinate there. And then I'm going to go over positive 5. And that all came from just being in this really nice, friendly form. So that's the benefit to finding your zeros, is being in that form. But part 1 says convert this to standard form. So what I'm going to do is FOIL, or expand this out. I'm going to multiply. I'm going to do the inside part first, and then I'll times it by 2. So I'll get x times x is x squared. X times 2, negative 5 times x, and negative 5 times 2. And then I'll times all that by 2 in a second. If I simplify this, I know this part here is going to be negative 3. So when I distribute that 2, I'll get 2x, and then negative 3 times 2 is negative 6. 2 times negative 10 is negative 20. And now this would be, you could say y equals, but that's the form that's in standard form. Okay? Now, neither of the forms that I have, the standard form or the intercept form, are really friendly for finding the vertex or axis of symmetry. So that means we'd have to do a little bit more work. And again, we learned the other day that our calculator will tell us all these answers, but if I was in standard form, remember the axis of symmetry equation? The axis of symmetry was opposite b over 2a. Well, I know what a is, I know what b is, and I know what c is. So, opposite of b, b is negative 6. So the opposite of that would be positive 6. And then 2 times a is 2 times 2 or 4. So I would get 6/4 or 3/2. So that's my axis of symmetry, which I'll add to my graph. Now remember, 3/2, that's the same as 1.5. So I'm going to go right here. Notice 1.5 is perfectly spaced between 2 intercepts. That also has to be true. And because, especially since I'm using my computer to do this, and I know this isn't very accurate, I'm going to label it so the person reading it knows. And you can put 1.5, you put 3/2 or 1.5, that's fine. now I need to find the vertex. And remember, the vertex is what happens when I plug 1.5 or 3/2 into the original function. And that's where I just grabbed my calculator. When you plug that in for x, you can use the standard form or the vertex form. You'll get negative 24.5. Now you should have got the same thing if you used your calculator as well. But I have a small problem on my graph. This graph only has 10 tick marks going down. So I need to adjust the scale because I don't want to just keep extending it. I need to adjust the scale. And even going by 2's here isn't really going to help. So what I'm going to do is I'm going to call each tick mark -3. Now you could do something different. It doesn't have to be this way. But this is kind of a nice scale because that's -3, -9, -12, -18, -21, and -24. Right? Did I do that right? 3, 6. Did I skip 15? It didn't look right. Thank you. Let's see. Another way to do it is 24 divided by 3 is 8. Should have 8 tick marks. 1, 2, 3, 4, 5, 6, 7, 8. So that'll be -24. Well, I have to plot -24.5. So it's not going to be right on that dot, and this is where it's not perfect, right? Which means I then have to tell the person reading this, where should that point be located? You could say 1.5, -24.5, or you could convert these to fractions too. It doesn't matter to me. But now I have almost everything that I need. The only thing that's missing is the Y-intercept. The Y-intercept is wherever the x value is equal to 0. And then you just find the y. Now, why is it beneficial to be in standard form? Because if I plug in 0 here and here, the only thing that's left over is the constant value or the c value. So now I know exactly where the y-intercept is going to be. Over 0, down 20. Now I know this is 24, so that's 21. The 20 is going to be just above that tick mark. And again, since my graph isn't perfect, I just want to label that so the person reading it knows exactly what that looks like. All right, and then my reflection. If I have a point, I can reflect it over. This point is 1.5 units away from the axis of symmetry, so if I go 1.5 the other direction, that gives me that extra point. Okay, and then I've got my smooth curve, and there's my parabola. So why do I show you this? One of your questions on your test, actually I should take that back. This is almost your entire test. Right here. You're gonna actually create your own equation, and we'll talk about that today. You'll create your own equation. You'll have to convert it to standard form. You're gonna have to graph and label all of these pieces, and then there's more to it. But this, if you feel confident in this warm-up, you're in a really good spot. Okay? Now I do want you to notice, look at my graph. Do you know the location of every single point on here? There's no guessing, right? It's labeled. Even if it's not perfectly graphed, each point is labeled so the person reading it knows exactly where things are located. And that's what I want to make sure you guys are aware of. Okay, so we are going to talk about the test today. We're going to do it after we review a little bit. What we're going to do, I forgot, this is our quote for the day. I saw this on Twitter. I just thought it was kind of cool. I might try to make a poster of it and put it in my girl's room. But it's just all the characters of some really famous women of history. Okay, we're going to do a Kahoot. Now, I'll just say this, I'm not super concerned if you guys are answering on Kahoot right or wrong. I'm concerned about, are you doing the work and working through it? So, what I mean by that is you can do it on your phone, you can do this on your laptop. If you don't have the ability to do Kahoot, that's fine as long as you're engaged in the problems. So I'll give you a second to get signed up here, and I'll pull up the Kahoot piece. And there's the game pin here. All right, so let's take a look. One of the things that we want to be able to do, notice right here, the A value is negative. When the A value is negative, that automatically tells you the graph is going to open downward. So just from this value being negative, that means it's either the blue or the red. It can't be opening upward. And then we are in vertex form, so it's opposite of what you think. This one, we would move 3 units to the right and down 1. So notice the blue graph goes 3 units to the right and down 1, and there's the vertex. There's proof that that's why it's the blue one. All right, next one. Which is the equation for the graph? So here's the graph. Can you match it to the equation? All right, this didn't work great last time. It's not, for some reason this isn't showing well. But you can see the parabola here. Notice how it's opening upward. So we have to have a positive a value. And then both of the roots are negative, but they're opposite of what it appears. So I have to have a positive number, which means it can't be the blue or the green. So it's either the yellow or the red. And then the plus 2 and plus 4, remember when you read those in the equation, they're the opposite of what it reads. That's your P and your Q. So my intercepts here are going to be at -2 and -4. And then in the equation, it would read x plus 2, x plus 4. So that's why it's the red one. All right, next one. Factor. Almost done. Okay, so this one you could do the box with the circle in it. However, if the a value is 1 and it's factorable, then you can really look at the last term. What are the factors of 12 that add up to give me 7x? Well, 3 times 4 is 12, 3 plus 4 is 7, so the factors have to be x plus 4, x plus 3. Again, if you didn't do that, notice the shortcut, do the box with the circle in it and you'll be fine. That's how you got the answer. All right, next one. Find the solutions. And the correct answer is 3 and 8, but let me show you how this would be solved. So what do we do first? The first thing is you have to get this in standard form. So you're going to subtract the 11x over, and then you're going to add the 24. Now at this point, this is another option where you don't have to show the box with the circle in it, because you could probably factor this in your head. How do we get 24? Well, 3 times 8 gives me 24 and adds up to give me 11, but both the 3 and the 8 need to be negative. So then my factors are x minus 3, x minus 8. And then you would set each factor equal to its own 0, and then solve, and that's how we got those two answers. Again, if you're not great with factoring, do the box with the circle in it, and you'll see how this appears, and everything will work out perfectly. All right, we do have another example where we'll have to factor without when the a value is larger than 1, so we can't do it in our head, and I'll model that just so you guys get some. All right, so let's take a look. This one was a little bit trickier. So we're going to actually do this one completely together. And I'll show you the ways you could approach this. Now, you might think, oh, well, they told me to solve, and could I do that by factor? Well, if I do that, I actually run into a problem with the box method. I only have 2 terms, and I don't have a third term. So without that third term, I can't complete the full box. So this method actually doesn't work when you only have 2 terms. So if you want to do a box method, you could, and watch how your box would actually be smaller. Now, we didn't show you this one directly, but this is one option some students like. Remember what factoring is. It's undoing the distributive property. So we're reverse multiplying. So how did I get x squared? I had an x and an x. And how did I get negative 6? I had x times negative 6. And here are my 2 factors for this piece. The other way to do it is right here. Look at these 2 pieces. What do they have in common? They each have an x. So I'm going to undistribute. I'm going to factor out that x. And what's left over is the x minus 6. And that's where these 2 pieces come from. But once you do that, now each one of these factors has to be set to its own, equal to its own 0. So here's one of my answers. It's already solved for. If x is 0, then this is 0. But what if x is 6? If I move the negative 6 over, I have 2 possible answers. And you could even check these and plug in a 6 here and a 6 here, and you would see that the left side equals the right side. So I just wanted to make sure that came up. That was something that we saw on a test or a quiz a while back, and I think that one kind of got us stumped a little bit. And it was just understanding what do we mean by the words factor. Factor is pulling out common terms, and if there's only 2 terms and they both have an x, you can pull out a common factor of x. All right, number 6, solve by factoring. This one, you most likely will have to show work for. Should have got x equals 4/3 and x equals negative 3. But why and how? There we go. So I had this from my other class, but I'll go through it. So if I'm going to factor, notice that all the values are over to one side. So that's the first thing, is we want to make sure that it's in standard form. And then we're going to multiply the corners. So I'm going to take the 3x squared times by the negative 12, and I get negative 36x squared. And then I got to look for factors of negative 36x squared that add up to give me that middle number of 5. Well, what times what gives me 36 that are 5 units apart? 4x and 9x. However, one of them has to be negative. And when they add together, I want the larger amount to be positive, so the negative belongs to the 4x. That's how you find the values that go into the box. And then we get to play that game of factoring. What do they have in common? So I can pull the 3x from the top row. The bottom row, I can pull out a negative 4. Vertically, I can pull out a x for the first pair, and then a positive 3 for the second. Now, the best part about this box method is you should be able to check. Does that fill in the box correctly if I multiply all the red terms together? Is each box accurate? Since it is, then I can write each factor equal to its own 0. And then we're just going to use algebra to solve. If I subtract 3, that one's really quick. For this one, if I add 4 over to the other side, and then divide by 3, I can just leave it as 4/3. So. That skill of factoring, you kind of want to check that off as you've mastered that for this unit. It's going to keep coming up over and over and over again, and we use it in calculus quite a bit. Question was, how did we get negative 36? So where did that negative 36 come from? When we do this method of factoring, our highlighter's taking a while to show up. Okay, well, I guess I'm not going to do it. My whole board just froze up on me. Let me try. All right, let's try this again. There we go. So where did this negative 36 come from? When I multiply the corners, we multiply 3x squared times negative 12. That's where the negative 36 comes from. And then we're looking for factors of that number that add up to the circled 5x. So I would, if you're not great with the box method, I might suggest coming in this afternoon to the Zoom session. And for anybody that needs help, we could go over factoring again. All right, next one. Oh boy, this is not working great. Okay, here we go. Number 7. Solve using the quadratic formula. There we go. So this is my work from the last hour, so we'll just keep it here. Notice it's written in standard form, so I can easily identify A, B, and C. And then we've got the quadratic formula written here. First step is just plug in everything. One of the big things is remember it's opposite of B. So in the equation, B is 5, so the first value is negative 5 plus or minus the square root. And then B squared minus 4AC. So I didn't show a ton of work here, but I said, well, if 5 is here, 5 squared is 25. And then negative 4 times 2 is negative 8, times negative 1 is a positive 8. So that's the discriminant. The discriminant is going to be 33. And since I can't reduce 33 down anymore, that's as far as I can go. And then just remember, we do have 2 answers, one with the plus and one with the minus. So that should be another thing you kind of check off your list of, do you feel confident in the quadratic formula? All right, and you can see that matches the answer that we had down here. All right. Keeper's on a hot streak. Question 8, simplify. Remember the complex numbers? The tricky one on this one is remember that this negative right here is subtraction. It does not mean multiply. So some students see the parentheses and think they should FOIL. That's not the case because in between that, it's saying you want a complex number minus a complex number. What I like to do is I like to think of that as a distributive property. What I mean is, think of this as a negative 1, and I have to change the sign or distribute those values. So notice this becomes a negative 6 and a negative 3i. And then we're just combining like terms. You're going to add the real parts together. Those are highlighted in yellow. And then you're going to add the imaginary parts, and that's where we come up with negative 14 minus 8i. So So usually I see students make an error because they think that that's multiply. It's subtraction because of the sign that's in between the numbers. So be careful on that. All right. Next one. Simplify. All right, nice. So this one, nothing super special. It's just addition. So then we're going to add just the real parts together. So you should get a -4 for the real portion. And the imaginary part is a positive 3i. Four players have hot streaks. Last one, simplify. I might just do this one from the start. So what would you do here? You could FOIL, or you could do just a regular old multiplication area model, and then we put the numbers on the outside, right? Because our goal is to fill in the area with multiplication. So what do we get? 2 times 4 is 8. 4 times -3 is -12i. 2 times I, and actually I'm going to make sure I just make sure that that's a positive 2i. And then here's the important one. -3i times positive i gives me -3i squared. But remember our fun fact? I squared is equal to -1. So I need to replace this piece right here. So if I have -3i squared, I squared is going to be replaced with -1. -3 times -1 tells me that this indeed is the same as positive 3. So we're still not done. Waiting for my board. It's really annoying. There we go. So we have the real parts that can be added together, and we have the imaginary parts that can be added together. So my final answer is 8 plus 3, so 11. And then the I portions add up to give me -10. Okay. Let's see where our podium is at. Alexis, nice job. And Kiefer. And Kyle. All right, nicely done. Big thing, can you confidently say, you know what, I feel pretty good in the material that we learned? If you did, you could take the test right away. All right, so we're going to take the last couple of minutes here. We've got 13 minutes left. We're going to actually show you your test right now. It's not due until April 4th, but here is, those of you in class, here is the test itself. So I handed a hard copy out to anybody who is present in class today. If you're in class tomorrow at all, and you want to stop by my room to pick one up, you can. Otherwise, there is a link, and I'll show you where that's at on Schoology. But let me show you the test first, just so everybody understands what we're looking at. So here's the test. Chapter 4, Summative Assessment. This is important. You need to show all work. I understand you can do this on your calculator, but you also need to show that work. Your calculator is really just for you to check that your answers are accurate. Okay? I'm going to be grading the work that you do. Now, task 1 is important. You're going to create a quadratic equation by selecting the last 2 non-zero digits of your school ID number and place them in the blanks right here where the question marks are. So here's an example. Let's say that Kishan has a school ID number of 1, 2, 3, 4, 5, 6. So the last 2 non-zero numbers are 5 and 6. So he would put a 5 and a 6 in this spot. Notice it's x minus 5, x plus 6. You have to make sure that your sign values are accurate, otherwise it'll throw things off. And then here's another example. Nellie, her number is 986002. She's going to select the last 2 non-zero numbers. So her numbers would be 6 and 2, and this would be her equation right here. All right, so task 1 is just filling that in, and that's your equation. Now, the nice thing is for the most part, everybody's going to have a different problem, which is why I'm showing you the test right now. So task 2 then is convert task 1 into standard form. Doesn't that sound a lot like our warm-up we just did? Task 3, use the quadratic formula to find your solution from the standard form that you just created in task 2. All right, and then step 4, or task 4, complete a graph using either the intercept or standard form. And this is where you want to show your work. And then notice what step 5 is. Identify. So basically, the work that you're going to do is really in step 5, and then you just got to make sure that's present on your graph. All right? So find the X-Intercepts, axis of symmetry, vertex, and Y-Intercept. So I know you hopefully can do this on your calculator, but you need to show your work in order to get full points on this. And then the last task I want to make sure everybody's understanding is we're going to use a complex number now using the same blanks that you created in task 1. So here it has 2 plus blank I. So you're going to create that. And if you want to put that in parentheses, that might help you. You can. And then 5 minus blank I. And then your your problem is to add those 2 numbers together and then multiply them. All right, so you get 2 points for the adding, and then you get 3 points for the multiplying, and that's what this means. And that's your test. So those of you that have the physical handout, there's a backside that you could show most of your work on, but I do want to make sure the work is neat and easily identifiable. I don't want to search all around, so if it's work for task 5, label it very neatly. Those of you that are on Zoom, you're just going to have this link open up. You can do your work on a separate sheet of paper. You do have to graph using graph paper, right? Everybody should have graph paper at home because you picked it up when you got your textbook. So let me show you just one last thing. Where do you find this? All right, so if I go to Schoology, here's our Schoology page, and I scroll down to week 3, in the agenda, it has the homework for tonight, but then you can go to the Wednesday folder. So if you go into the Wednesday folder, everything is right here in this red folder that says Chapter 4 test. When you click on it, I wrote just some things that you have to be aware of. Read this, just important. It's what we talked about. Notice it's not due until Sunday, April 4th, which if you have questions, that gives you a couple of days to get caught up. And then if you click on this link, it will open up to the image I had just shown you. Okay, and then here's where you submit a picture of your work and you submit the test.
and do that all by April 4th. There's a question after this unit, will we be using more graph paper? Yes, we will. If you need more graph paper, you can always, I've got a stack of it in my room. If you're in the building, stop by my room. Or if you're at home, you have a couple options. You could come into Tartan, and in the media center, we have graph paper there you could get. Or if you have the ability, just go pick up a graph paper notebook at Target or something. But we're going to be graphing all trimester long, so you're going to need graph paper all year. So here's what we got then for today. Your goal by April 4th is to finish all missing work for this unit and then to complete the test as well. So everything has to be done by April 4th at 11:59. If there's any questions, let me know. Otherwise, those of you on Zoom, you're free to leave. So then our afternoon session today is going to be, do you have any questions from previous homework? Maybe it's using your calculator, any of the graphing stuff. And if you're comfortable, then you can start on the test, and maybe you get everything done before you leave school today. If you need graph paper, I have it right here. Please grab a couple sheets. Thank you, Caitlin. Have a good weekend. Hey, Odin, are you there? Hello? Odin? Any questions? So, anytime you want to find something, you do the help feature, so the second trace. And then, so you want to find 0, so it's going to set for on. Now, 0 is only ever cross this X line. So, I want to go here, notice this left down. What I would do is let's bring that cursor so it hits that where we think the 0 is. So that's the Y-Intercept. So what I would do is, roughly right there is where we think our X is meeting. So when it says left, hit the left arrow a couple of times. So now that just brings it to the left. Now it says right bound. Now we have to hit the right arrow until we get past the 0. Right there. Yep. Yeah, that's a little far, but it won't matter. So hit it here. And then after you get gas, hit it here. And there's your answer. So notice it's not too friendly, but that's your first 0. That's the location where that flashing out is going. And now
now we work on the next one. So now we'll go back to the second row. Now, notice it says left down. So you want to bring it to that to 0. Yep, and now hit the left arrow a couple of times so you go past it. That's fine. Hit enter. And it says right down. Now you guys look to the right of where the 0 is. Okay. And there you go. So that's how you find the zeros. So the Y-intercept is value. So you hit enter. And it says, what do you want X to be? Well, X is always 0. So anytime you find a Y-intercept, it's hit 0. It'll bring you right to that. So, we got about 30 seconds here. I'll touch base with you guys to see if we have any questions when we come back. Otherwise, you guys could finish your test today. Or maybe you're mostly done with it already.